So part C, yes. So they want the equilibrium point, the a consumer surplus and the producer surplus at the equilibrium point. Fine. I have to find the equilibrium point. And we are given both functions, so we have to set d of x equals s of x. Where's my d of x? Here it is, 0.425 x squared minus 5.7x plus 22.5, and it equals the supply function 0.3x plus 5.3. Okay. So 0.425x squared, I subtract minus 6x, and I subtract plus, what do I get, 22, so this is 2, and I think that this is 17. Correct me if I'm wrong. So 22.5 and 5.3, yes, 17.2, perfect, equals 0. Okay, I can use the quadratic formula, but I'm much faster with my TI-86. Okay, I will punch in 0.425, negative 6, and 17.2, and I want them solve for me. So x equals 10.11 and x equals 4. Okay. It says he buys no more than 6. So we are told that x is not more than 6. Therefore, we will have to exclude this possibility. Algebraically, it's correct, but we have to exclude it. So at this point, we are asked to find the consumer surplus. Should I graph it again, or we picture it without graphing? So x is 4, and I have to plug in and get the y value. Where is my function? Here. So 4 times 3 is 1.2, and 1.2 plus 5.3 is 6.5. So I found the equilibrium point. Quickly, I want to multiply 4 by 6.5 because I need that area, which is 26. Do I need to graph again? You want me to graph or not? Or is it clear now? Okay, well, the integral from 0 to 4 from the demand function, which is this, 0.425x squared minus 5.7x plus 22.5 dx, but minus 26. Okay. So we have 0.425x to the third over 3 minus 5.7 x squared over 2 plus 22.5x from 0 to 4 and minus the area of that rectangle. Okay, so let's see what I get. 0.425. I hope that anyone is working with that. So 4 to the third is 64 divided by 3 minus, so this is 16 divided by 2, so 5.8 times 5.7 times 8, and plus 22.5 times 4, and then minus 26. I got 27.47. Okay, now we want to determine the producer surplus. Which will be 26 minus the integral from 0 to 4, but this time from the supply function, 0.3x plus 5.3 dx. So this is 26 minus 0.3x squared over 2 plus 5.3x from 0 to 4. And let's see directly, 26 minus 16 divided by 2 is 8, so 0.3 times 8 minus, because I have to distribute, 5.3 times 4. I don't plug in 0 because I will get 0. So I got 2.4. That's the producer surplus. Any questions? Any questions? Any questions? Okay, well, the last section of this chapter deals with differential equations. What is a differential equation? It's an equation that has derivatives in it. So on page 509, I would like to start with something like 13. And this is a differential equation. Why is this a differential equation again? Because it has a first or second or both or more, at least one derivative in it. So it has the function. It doesn't have to have the function, but it has the function, it has the derivative, the first derivative and the second derivative. This is what is called the differential equation. We are asked in part A to show that y equals e to 6x is a solution. Show that is a solution. No problem. I will replace this by e to 6x. I don't know yet what to replace this by, but that's not a problem. Y prime is e to the function times the inner function prime. So this is 6e to 6x. I don't know what to replace this by, but in a minute I will. Same thing, so it's 6 times e to 6x times the inner function prime. So this is 36e to 6x. Now I will plug in everything. I will replace the second derivative by this, the first derivative by this, negative 30 times the function, and see if I get 0. If I get 0, then I will say, yes, indeed, this is a solution of that equation. Okay. So I'll start with the second derivative, which is 36e to 6x minus the first derivative and minus 30 multiplied by the function. Does this equal 0? It does. 36, they're all the same. 36 minus 6 and minus 30 is 0. So I will say yes. Y equals e to 6x is a solution of the differential equation given. In part B, they're giving us another one. And we're told, show that this one is also a solution. Fine, no problem. Same idea. We're given that y equals e to negative 5x. They're telling us that even this one is a solution to the same differential equation. Show. Fine. I have this piece, which is e to negative 5x, but I have to determine the first and the second derivatives. So y prime will be e to negative 5x times the inner function prime. So this will be negative 5e to negative 5x. And the second derivative will be the same thing, negative 5 times e to negative 5x times the inner function prime, which is negative 5. So the answer will be 25e to negative 5x. What I have to do is plug them in and see if I get 0. So the first one is replaced by the second derivative by e to negative 5x. Minus this, but I have to change the sign, plus 5e to negative 5x, and minus 30 multiplied by e to negative 5x. Is this 0? Yes, it is, because this is positive 30 and this is negative 30. They all have e to negative 5x. And I'll say yes. Even e to negative 5x is a solution. Of course, y equals. We also have part C. Same question. In part C, they are giving us y equals c1 e to 6x plus c2 e to negative 5x is a solution where c1 and c2 are constants. As you see, what happens here is just a linear combination of the previous two solutions. So even this will be a solution of the second derivative minus the first minus 30 times the function equals 0. I have y, but I have to determine y prime and y double prime. So the first derivative will be 6 c1 e to 6x, and then minus 5 c2 e to negative 5x. And the second derivative will be 36 c1 e to 6x, and plus 25 c2 e to negative 5x. All I have to do at this point is just plug them in. The second derivative by this, the first derivative by this, and y by that. And show that it equals 0. So I replace the second derivative first, of course, c1 e to 6x plus 25 c2 e to negative 5x, minus the first derivative, minus 6 c1 e to 6x, but plus, I have to distribute, 5 c2 e to negative 5x. And now I'm distributing negative 30 to the function. So minus 30 c1 e to 6x and minus 30 c2 e to negative 5x. And we hope that this is 0. We'll see. So I'm looking at the terms with c1. 36 and negative 6 and negative 30, yes, they go away. Now with the terms with c2, because that's what they have, e to negative 5x, 25 plus 5 is 30, minus 30 is 0 indeed. So I will say yes. Yes, even y equals c1 e to 6x plus c2 e to negative 5x is a solution. Now, we do have something called separable differential equations. And this is the only type that we really look at, other than the simple ones. This is the only other type of differential equations, in this class anyway. What does that mean? And I'll take an example. I want to start with a simple one. Yes, so on page 510, let's start with 35. dy over dx equals 4x cubed y. We're asked to solve this differentiable equation. Okay. So the idea of separating the differential equations is have basically one variable on one side and one variable on the other. As you see, dy over dx, we know that that is nothing else but y prime, But in this case, we're going to treat it as two separate differentials in order to solve the differential equation we have here. In other words, dx will be separated from dy. I will use the cross multiplication rule and somehow have only y on one side and only x on the other. You can write you can apply the cross multiplication rule first if that's what you want. So this will be dy equals 4x cubed y dx. But then I have to divide both sides by y, because the y should not be on this side. So it should be on this side. So at this point, I realized that all terms or quantities or anything that has y is on one side, and anything that has x is on the other. So the two variables are separated for the differential equation here. Now, two quantities are equal. I can integrate. I can integrate the left-hand side with dy that is already there. I don't have to write it. And integrate the other side with dx. Okay. We're going to use only one constant. And we know that when I differentiate this, I will have one constant. When I differentiate this, I will have another constant. It doesn't matter. We are just going to use one constant, only on one side. Okay, so how do we proceed? What function prime is 1 over y? And we remember that that is natural log of the absolute value of y. On the other side, I take the constant outside, and x cubed becomes x to the 4th over 4 plus a constant c. Of course, I will simplify. And remember where I'm solving for y. Solve for y to find the function. Okay. So this is the natural log of the absolute value of y equals x to the 4th plus a constant c. Can anyone tell us if anyone remembers how to change this into an exponential equation? Anyone?